Here we have a function f of x is equal to 3x minus 5. What we want to do is first find the limit as x approaches negative 1. Again, this is linear, so you can graph this out and take a look at what happens as x does go to negative 1. We can also use direct substitution, so if we plug this in, we have 3 times negative 1 minus 5, which is negative 8. So we believe that the limit, which we'll call L, is negative 8. Our proof is going to go something like this. We want to let epsilon be any number that's positive. In fact, as small as you can possibly try to make it. So we say this, we say let epsilon be a positive number, and let's let that be given. We have to choose a delta value equal to something. Now we're going to come back to that and we'll fill this in. If our x values are less than some delta value, which we're going to pick, if that's the case, then we need to show that the function values away from the limits are less than epsilon. So what we do, so let's do some side work. Essentially what we need to do is we need to get f of x minus L to be less than our epsilon. So we need to write delta in terms of epsilon, so you're going to see an epsilon over here, so that this holds true, given we already know this guy. So given that our x values are really close to negative 1, we need to show that the function values are really close to negative 8. That's the idea of a limit. So what do? Well, let's plug in what we've got. We know the function. Okay. The function is equal to 3x minus 5. So we know that f of x minus L is equal to 3x minus 5. And now we're going to subtract the limit, which we know is, well, we believe is negative 8. So now what we do is we try to reduce this, and we want to write it so that it looks like this guy, which, by the way, is equal to x plus 1, the absolute value of x plus 1, because it's minus a negative. So this, you'll often see written like this. So let's continue. This is 3x minus 5 plus 8, which is equal to 3x plus 3. Now we're going to factor, and we're going to get that. Notice how this is looking really close to this. So let's keep working. This is the absolute value of 3 times the absolute value of x plus 1, which is 3 times the absolute value of x plus 1. Now, the absolute value of x plus 1 is less than delta. So this guy right here is less than our delta value, which means that this guy right here has to be less than 3 times delta. So now watch how I'm working that out. Let me do it, I'll do it up here and then I'll erase it. So what I have is absolute value of x plus 1 is less than delta. That is this up here. That's already given to us. So I want to have 3 times the absolute value of x plus 1. So if I multiply both sides by 3, look what I get. That's where this came from. Okay, now I want this guy to be equal to epsilon. I want it to be equal to epsilon, because what that does is if this guy is equal to epsilon, then f of x minus L, as I carry through, oh, it's less than epsilon. So what I do is I take this last thing right here and I set it equal to epsilon. By setting equal to epsilon, what that means is that, so 3 delta is equal to epsilon, which means delta is equal to epsilon over 3. I've now figured out if I pick delta to be epsilon over 3, then 3 times delta is equal to epsilon. Watch, because if delta is epsilon over 3, then this becomes this, and these guys cancel out, and it's equal to epsilon. So the trick here is to first write your f of x minus L, and you work it all the way out, and you make it look like this guy up here as best you can. Now you're usually going to have like a number out in front, and notice that this number is the slope. So when you're doing linear ones, this number up front will be your slope. Now watch. Or the absolute value of your slope. Think about it that way. Be the absolute value. So once you get this right here, you want it to be less than, in terms of your delta. So less than, I got 3 delta. And I want this thing to be equal to epsilon. So to make it equal to epsilon, I choose my delta to be epsilon over 3, which means that up here, our delta value is going to be equal to epsilon over 3. And if that's the case, then this guy, we just work our way down now, just like we did here. So we don't have to show all these steps, okay, but we'll show a couple of them. You can leave some to the reader, but you can't just jump from f of x minus L is less than epsilon, because that doesn't really help us with the proof here. So this is going to be 3x, oops, so let me say, therefore, f of x minus L is less than epsilon. So notice that f of x minus L is this guy right here, and it's less than epsilon. Thus, we have the following. The limit as x approaches -1 of 3x minus 5, we've just proven that is equal to -8. And so this guy up here in green, this is your proof. Okay. So the green thing's your proof. Okay. The blue stuff is kind of the side work. So this green stuff is what you would hand in for your actual proof. This other stuff is what you did to work out, to try to figure out what you had to put in there, especially for this delta is equal to epsilon over 3 for this piece. So your big problem is trying to pick this. So to pick this, you gotta work through this down here.